counting duplicates with COUNTIF and some productive. So we'll count the duplicate items. So before we go on to the next section of the course, I wanted to add one more hands-on demo. It does a really good job showcasing how you can combine these different stats functions to do some really interesting things. And in the demo that we are about to walk through, we are going to combine the count function, which we just talked about, with that strange and mysterious sum product function to actually count the number of duplicate items between two lists. So go ahead. We'll proceed with this. Almost. Hanka खोल if in some product, if you don't means like you are using an older version of the file, um, I don't read this duplicate items. And what we are looking at here are the grocery list for two roommates, Ben and Jerry, and both Ben and Jerry are going grocery shopping today. And the last thing that we want is for them to both purchase the same item for the apartment. So this will be a great opportunity to use a self function to actually count any duplicate items that exist in both Ben's list and column B and Jerry's list in column D. So now before we go crazy and just to start typing some product and counting functions, right here in the cell F, this is the cell F, and we have B, column B for Ben's grocery list, and column D for Jerry's grocery list, and here we will count the duplicate items in the F3 from F3. Yeah. So what I like to do when I'm kind of pursuing these more advanced techniques or formulas is break them down into their most basic component pieces. Make sure I understand those components really, really well and then assemble them into the final result. And so that's exactly what we're going to do here. So we are going to start by just adding some workspace here. Right click. One second. So in the F we have this thing and okay. Let me okay. So we are going to start by just adding some workspace here. Right click and stretch out both. I will stretch out both E and F. I'll let you know what I'm doing now. So this is going to be kind of a sandbox or a working space which we will end up deleting before we finish. So, and the second thing that I'm going to do just as we get prepped is instead of referencing these list as like these list as cell reference like B3 from B3 through B25, I guess the last cell is still B25. Yes, let's give them some meaningful names. That's going to be what to say like that's going to help simplify things and make our formulas more readable. So using that name box right to the left of the formula bar, uh, wait, so we have from B3 through B25, and we will simplify things. So using that name box right to the left of the formula bar, we are going to type Ben. So in the name box we have, right, this is the formula box. Here we have, so when we click on, so I have got Ben's list selected, so I'll press enter. So this is the Ben's list. Same thing with Jerry also, like if you give Jerry, so you can see I'm going to select cells D3 through D25. From D3 we will call that one Jerry. All right, so now there are two ways we can solve this problem. We can either figure out the number of duplicates in Ben's list that exist in Jerry's, or we can figure out the duplicates that exist in Jerry's list from Ben's. And it's kind of two sides of the same coin. We are going to get the same result, but we can use two variations of the formula to do that. So for the sake of example, let's walk through both. I'm just going to add some headers here. First we are going to say duplicates in Ben's list. Same thing here also, but here we'll say Jerry's. And to calculate these duplicates, we're going to use just the COUNTIF function. Pretty straightforward. So um, here. So in this case, duplicates that exist within Ben's list, we are basically searching Jerry's list. And here I'll D3. One second, wait. So in this case, duplicates that exist within Ben's list. So we are basically searching Jerry's list, and so if you see here, if I drag this, if I drag that, I should get the Jerry name Jerry. not getting this. Let me do one second. And yesterday I did it came. अब मोजता नहीं. Okay, no problem. Maybe I updated my version, so it is not giving me. So if I press Jerry, so you can see I got the Jerry option here. So in this case, duplicates that exist within Ben's list, we are basically searching Jerry's list, and I can drag and select and it will update to a name range Jerry. Like, or it can simply I typed Jerry. So I'm searching within Jerry's list, and the criteria is the first items in Ben's list. Feels a little confusing, but don't worry. But you will see what I mean. What we close this out and press. So 1 second, wait. So here Jerry criteria will give the Benz B3. So we close the parenthesis and hit enter. So if you see, Washington cranberry juice. Washington cranberry juice, you can see it is not there in D list. We have Washington Diet Cola, we have Washington Diet Soda, we have Washington Apple drink, we have Washington Mango drink. So we are getting 0 here. Okay, and then we have Green Ribbon Canned Peaches. So we can see we have one here. Green Ribbon canned peaches, only one. Yes. So wherever there is one, we can see that that is also present in Jerry's grocery list. So this is just to find the duplicates between two columns with the help of COUNTIFs. So Excel is checking each item in Ben's list. It is comparing it against the entire range containing Jerry's list, and it's returning a count of the number of instances. So if that item, as I said, Washington cranberry juice does not exist in Jerry's list, we will see a 0. Which does exist, we will see a 1. So at first glance, this tells us that we have got some duplicates. Green ribbon canned peaches also appears in Jerry's list. Blue label fancy canned oysters wolf also appears in Jerry's list. And it looks like one other duplicate, which is club string cheese. So by simply selecting that range, you might start to realize that we can simply take the sum, which is the 3, and that gives us answer that we need the number of duplicate items. There are 3, and that would be just fine. That gets us a little, like we have 1 2 3, only 3 products are duplicate. But we are going to get a little bit more elegant here. So, and the first thing that we are going to do is actually change this reference to be 3. So what I will do, I will change this reference, not B3, I'll just say Ben. Even though we are referencing that full grocery list each time when we drag this, so even at that time we are getting the same, we'll get the same answer. Yes. Of 1 7, even though we are not telling B5, B6, etc. So we are able to simplify things a bit by simply referencing each of the two named range. And now very similar process, if we want to flip the coin here and count duplicates in Jerry's list fact, we can copy and paste that a function from E3. So you can copy the same thing, and you can just interchange the,
Names.
yes, Ben and Jerry. So it will be the same thing. So you can see the blue canned peas have 0. Height of floor is also 0. Club string cheese is 1 because there is club string cheese here. It reverse the order. So it will just interchange the order, but the result will be same. So and you will notice two interesting. First is that you still get this array of ones and zeros, but the ones are located on different rows. Club string cheese, green ribbon, canned peaches, and those fancy canned oysters. For those, there will be one. So it's the same 3 product gives us the same sum of 3, but it's calling out the rows in the um, location that they exist in Jerry's list versus the location that they exist in Ben's list. So regardless of which list we use as our source list or our first argument account, if function, we are going to get the correct answer. So now all we need to do is basically sum up the results of that count function to boil it down into our single answer, which in this case we know will be three products, and that's where some product comes into play. So right here in G3, let's start with a sum product. So here I give the sum product. Sum product, then COUNTIF. So start with Ben or start with Jerry, doesn't matter. So we have embedded that whole matrix of values, and then sum product is adding all those values up within one single cell. So press enter. So you can see. So sum product is 3 and we're getting. So there you go. We have our answer of three products, and check it out. So instead of writing, 22 functions here in 22 cells, like instead of writing these things, duplicates in Ben's list, duplicates in Jerry's list, just you can give this formula directly. So it will sum product the countifs and it will give the answer. The same answer you got 3 and 3.
Okay.
We have achieved the same thing using one single function, and that's the power of sum product. So with that, we actually don't need these cells anymore. So you can delete those. So that's kind of a crash course and how you can combine COUNTIF and sum product. So we'll move to the next thing. The next is data profiling. This is a pro tip, like this you will see on day. This you will do on daily basis. So we'll see what is data profiling. One second. All right, so let's wrap up this section with a demo that kind of ties together all these different stats function we have been talking about. So we are going to put into work COUNTIF, sum product, and apply those to an actual real world analytics by use case something called data profiling. Now, when I talk about data profiling, what I mean is generating an understanding of the quality or distribution or characteristics of a data set. So so we'll proceed with Excel. So I have opened my data profiling tab. So we'll see what is this, what we have in this tab. So now what we are looking at here is a very simple small sample of customers. We have got here 10 different customers we have 10 different customer names here along with the city, state, and zip code. And for this demo, the zip code field. Okay. And for this demo, as I said, the zip code field is the one we really care about. That's the column that we're going to profile here. And what you will notice is if you select at uh, F3 through F12. If you select it, I have named that range zips, and that's, you can see here, zips. And that's just going to make a formula a little bit more intuitive and a little bit more human readable. So I've also built this little template here with the some of the data profiling. So you can see here one template. So some of the data profiling use along with the world's tiniest bar charts. Here we have the bar charts. Okay, you can see the bar charts. So just to help us visualize how many of our records fall into each of these categories. Now keep in mind there are many more data profiling metrics that we could see. So we are going to focus on some of the most common ones, like the row count, distinct records, blanks, and numbers, and valid records. So these are the data profiling. So don't worry, as we complete this you will understand more clearly. So we have already started by populating the total row count. So here you can see the total row count, it is already populated, and for that we are using the rows function, which we will talk a little bit more in depth about in the coming section, lookup reference section of the course. But basically all you need to know is that rows will count every single row in that reference, regardless of whether it's a blank numbers, text, and so on. So press enter. So we have got 10 records in our sample. Now I'm going to skip past distinct for now, because it's past distinct, because it's going to be our most challenging case for this demo. And let's just bang out the blanks. So we'll skip as of now this. We'll see next in next section, and let's work on the blanks, numerical values, and valid record section, because those are a little bit simpler and quite a bit more straightforward. So to count the number of blanks in the zip code range, lucky for us, Excel has a very helpful formula called count blank. So you can check the blanks with the help of count blank. So you can see we have got already, and all we need to do is feed it our zips range, press enter. So here you have the range zips. So you can see we have got 3 as the answer. So you can see 1, 2, 3. So the count blank will give the blank in that particular column. So we get 3 because there are 3 blanks in rows 4, 9, and 11. And the next up we have got numerical values, and the reason we are counting this and treating it like a bad thing is because remember, zip codes are not really treated like numbers. We are never going to be aggregating them or adding or subtracting or multiplying zip codes together. So in this case, if someone enters a zip code as a number, that's a bad thing. So to count the number of numerical values in our range, we are going to use the simplest function of all, just to count. So remember, counts the number of cells in a range that contain numbers exactly what we want. So let's feed it that zips range. So you will understand in a bit of moment. So we have zips range. Okay. And we get a 1 because this one zip code all the way at the end looks like Evan entered it as a number. So where is E1? And this person has entered it as number. You can see the comma here. So then Excel will think that as a new numerical value. But other people, you can see Jennifer, Susan, and Van and all, they haven't entered any comma. They have just given the numerical values. See, is zip code, we will not work with zip code. We will not add it. We will not subtract it. So no one will consider them as a numerical things. Okay, but Ivan has given comma, so our Excel is considering that as a numerical value.
Okay.
So, and all of our other zip codes here are treated like text. So in fact, we actually use a special formatting category for zip codes specifically. So you see, format cells. So we have special category for zip code only. Format cells. Um, so we have special here. So we have special formatting category for zip codes specifically. Okay, yesterday I updated, so it is not no issues. We'll see it later. We'll check some other things. So last but not the least, we have in this little section we want to calculate valid records, and if we are defining valid as non-blank, like a non-numerical, so we want a text field that contains something, anything, we will call that a valid record. So there are two different ways we could do it. In fact, there are many more than two, but two common ones. For one, if we know the total row count and we know the blanks and numerals, we can simply say 3 a3 and 1 and arrive at the valid records of 6, which is correct and accurate. Like here we have 3 1, right? 4, so row count is 10, so 10 minus 4 6. So 6 will be the answer, but still instead of that I'm going to show you a really helpful little shortcut, which is using the wild card in accounting. So counting, so we'll write a formula, COUNTIF, and then range I will give zips. So this will be our range. So and check this out, our criteria. Remember, we are looking for text that contains anything non-blank text. What I can do is open a quotation mark and use the asterisk wildcard. So asterisk. That's the wildcard that basically can account for any number of characters, no matter what they are. Close the parenthesis or the quotation mark, then the parenthesis, press enter. Insert. Okay, I did not give comma. So you can see 6 here. So it has subtracted the blanks and it has, so our Excel will consider the valid record is the one which is having only text. It will not consider numerical value, because in the zip we are only considering, for the zip codes we are considering only the text, not numerical value. So what it will do, it will 3 plus 1 4, 4 minus 10 is 6, we are getting the same value. So there are 6 valid records in zip code. So 1 2 3 4 5 6. So it has not considered this as a valid one. So and that gives us the exact number that we need. Now it's time to move on to the trickiest one of all, that is distinct records, which is the distinct records value. So this one's funny because it sounds like it's something that should be quite easy to do. In fact, your instinct might be to start typing something like this: counted distinct of zips. Problem is you get the name error because if you see, if I give count, we have count distinct also. Don't have. Yes, we will get a name error because we don't have that formula, because Excel doesn't have a function called count distinct. I wish it did, but fortunately it does not. Now, if you are using Office 365 and you can have access to some of the newer dynamic array function, there are some formulas like unique that will make tasks like this much easier. But for now, with the tools that we have, unfortunately, counting distinct is a pretty tricky exercise. So, but we can make it work. So let's go ahead and delete this one. What we are going to do is take a similar approach to the one we took counting duplicates in our Ben's list, Ben and Jerry example. Remember, we combined sum product and count if we iterated through those lists and counted the number of instances of each value. Well, we are going to start with the same approach and then make a few little modifications to suit our needs. So follow along, like we're going to build this up step by step. So what I'm doing is I'll put the sum product, then, and the array of values that we want to sum up is going to be generated by COUNTIF, just like a example in our duplicate one. So and what we're doing here is we want to count the zip codes in our zips range. So I will do sum product and then COUNTIF, what we did previously, and then I will give the zip range. Our zip range, then, and the criteria that we want to evaluate is basically iterate through zip by zip and tell me how many times that zip appears in the criteria range. And because both arguments are referring to same range here, we just need to reference zips one more time. So we'll put another time. So we close this. So zip is the range, and even the criteria is also zip only. We want to find the distinct value within this only. So both will be zips. So distinct records are 9. So shows 9 distinct records, and even just at first glance, we know that's incorrect because there are fewer than 9 distinct records here. We have got 3 blanks, and it looks like zip code appears twice here. So you can see 0704 has appeared twice. We have got 3 blanks in the rows 5 and 7. The 0704 appears, so 9 is clearly over, like counting the number of distinct records. So if you remember, some product works like an array function. It iterates through each row in a range and generates an array that you can then perform operations against. And the best way to troubleshoot and diagnose these types of formula is using the evaluate formula tool. So if you're on, so if you check this, and we have formulas and evaluate formula, so you can evaluate. So it is taking f3 to F12. The zips is the range, so it is taking F3 to F12, and the zips you can see here, the criteria is also zips. So you can see criteria it has taken as the sector. So 62013, for the blank it has taken 0, and then 0704, then the 2248. So wherever there is blank it has taken 0. Then some product. So what it is doing, 1 0. So 62031 is occurring only once, so it is giving 1 there. Then you have 0 because blank, then twice because 070 has been twice, then 1 2248. Then again for 0704 it is giving 2 because it occurs twice. Then 97201 has 1 because it occurs only once, and then blank has 0, then other one has 1, and next is
Then
blank,
again
and
one.
yes. So
Okay.
evaluation is 9. So like this you can check what is happening step by step, whether your formula is correct and whether it is fetching the right values at each step. So you can do like this. One second, excuse. So next one is, so let's close this out and think about how we need to modify this to suit our needs. Well, first thing that you will notice is that in any case that appeared, or any zip code that appeared two times, gets double counted, right? Because in our resulting array, where did it because in our resulting array we showed a 2 for this zip code and a 2 for the duplicate version also. So which is completely inflating our numbers of distinct records when we add those numbers up. In fact, if there are two instances of a zip code, what we want is for each of these zip codes to take a value of 1/2 in our resulting array, so that when you add both together you get a 1, because the two of them represent one distinct value. So in fact, if there were three instances of the same zip code, we would want each to take a value of 1/3. So all the three, when added up, represent one distinct record. So in order to make that work, what we are going to do is click right before. See, here we have only two. It is fine. Okay. What if we have three times? At that time, what it will do, we will see that. So we'll see what we can do. So in order to make that work, what we're going to do is click right before the count. So before the count, if you are going to add a numerator 1 divided by that count, if array, and let's just start there. So what we'll see, 1 divided by, we'll see if I give enter, we'll get a, okay, div by 0 error, which means we are not quite done yet. But to diagnose, we are going to go back to our trusty evaluate formula tool. So we'll again go back to evaluate formula and see what's going on. So again, zip ranges F3 through F12, our zip arrays, we are going to perform our COUNTIF. So you can see COUNTIF F3 to F12, and then we have our arrays. We are going to perform our COUNTIF, get that some array of 1 0. So you can see 2 1 and 2, so on. Again we got, and now we are dividing 1 by each value. So 1 by 1, 1 by 0, that array, thus going to turn the 2's for zip code. So you can see, so it has divided 1 by 1 and 1, and for 2's it has given 0 0.5, and for 1 by 0 it is giving div by 0, which is exactly giving the array, but here it is giving 0 0.5. This is exactly what we want. The problem is that the zeros are going to throw our errors, and then we try to take the sum product. So if I evaluate, so sum product, and added those up, we are going to get a div 0, which you see an error for. So we are getting closer. We got what we needed at 0 0.5. So when we add that, it will give 1. If we add, sorry, if we add those 0 0.5, since this is a sum product, we're adding 0 0.5, 0 0.5, 1. See, 1, 2, 3, 4, 5, 6. So we had to get 6 as a distinct value, but we have got 9. Sorry, not. Yes. So we will deal with the zeros. So here is a little trick here. Instead of looking at the zip code values as is our criteria array, all I'm going to do is use an ampersand and concatenate a blank empty space there. So zips and then blank empty space, and what's going to do is tell Excel, hey, don't just give me the list of values, those 10 zip codes in the array. I want you to append a blank to the end, and that's going to turn it into text. So it's not going to change the number or add a character or anything. It's just telling Excel, treat the values in that array as text. So press enter. So if I press enter, hey, look at that. We got 7 as the answer. Now we have got 7. We are getting closer, right? So, and if we evaluate the formula, you can see if I evaluate for the next step, what it is doing. Okay. You can see F3 to F12 and reevaluate our zip just like we did before. And now when we add or append or concatenate that link blank string at the end, watch what happens when we evaluate that. See, once again I'll show you again. Mhm. See, before ampersand, before concatenating this double quotes, you can see we had here as only zero. Wherever the blank was there, there was only zero. But after ampersanding, like after concatenating those quotation mark, that zero also will become as a text. You can see the zero has come under the quotation mark. So now it will consider that also as a text now. So next, for the next step when we evaluate, you can see one by this thing. So it is not a zero, it is a black string, blank string. And so 1 divided by, we have got here div 0. We have 3 div zeros now. So 3 div zeros, it will consider as so what it will do now, it will submit. So we have got 7. Wait, I will give the difference now. So we have seen that I give zip. It is a little bit tricky, so you just have to.
It is kind of very time consuming, I feel.
Yes, yes. See, if you see, I have not given the ampersand and that double quote marks.
Hmm.
So if I evaluate, you can see
Yeah.
till here, and here you are seeing 0 only. So 1 div 0. So getting div 0. Okay. If I since I updated it, it is not that older version was only fine. In that older version, we would have got here as a blank. Here there will be no zero. It is just showing as this, but in the background it will be as a blank string or zero string. So
Okay. Let it be, ma'am. It must have got updated. Let it be.
yes. So you are getting 7 as the answer.
Yeah.
So
Okay.
now that now the blanks become one distinct value. The two zip codes that were duplicated, one distinct value, add it all up and we get a 7. So we are almost there, right? So and if you want to treat a blank zip code as a distinct value, then you are done. This is accurate, but if there never should be a blank value there and you don't want to treat the blank as a distinct record, so there is one other tip I can show you to help you count for that. So and basically what we want to do here is multiply the resulting range that we got, the array that we produced by another array, that will essentially allow us to filter out or ignore any rows here in our range that are blank. So we'll see how to do. And so to do that, I'm going to replace the one that we had written with a logical statement here. So I'm going to open up a new parenthesis here. I'm going to open up a new parenthesis. Going to say zips. So this will say zips blank. Close the parenthesis. Then press enter. So you got 6. So 1, 2, 3, 4, 5, 6, 7. So we are not treating blank as the any character or the new in anything, any record. We are just taking the blank, the cells which have the records in that. So we have 6 distinct records we got. So if you want to evaluate formula, you can see. So true we got. That also will give 6. Okay, you want me to explain this 6 1,
No,
this one?
ma'am, no. No need.
Oh, okay. So this is what it is. So next we'll see. Next section is the lookup and reference functions. We'll see what is v lookup, h lookup, and how to how to work with them, how to troubleshoot the error and all. Next we'll see the text functions, next date and time functions, next to formula based formatting, and then we have dynamic array formulas. Then
Okay.
uh, we have some bonus functions also.
Okay.
So for lookup, let me just give the introduction for lookup. I want to open.